Hey everyone, welcome to This Explainer. Today, we are unpacking a seriously fascinating piece of tech history. We're looking at a programming language that's, well, over 40 years old now, yet it is still quietly running almost everything in our modern world. I'm talking, of course, about C++. So think about this for a second. What do the massive multiplayer game Fortnite, cutting-edge artificial intelligence, and the actual operating system running on your computer right now all have in common? The answer isn't some massive corporate monopoly or a newly discovered microchip. No way. It's an invisible foundation of code written decades ago. Let's find out how it got there. Okay, let's dive into this. Here's our roadmap for today's explainer. 1. The problem with C. 2. Birth of a super language. 3. Growing pains and standardization. 4. Powering modern video games. And 5. C++ in today's world. All right, Section 1. The problem with C. The 1970s software dilemma. So back in the 1970s, the C programming language was absolutely incredible for raw speed and efficiency. I mean, it was perfect for operating systems. But, there was a major catch. As software projects scaled up and got bigger, they became wildly complex, just a nightmare to manage. Developers desperately needed the organizational advantages of object-oriented programming, and they needed a way to mash together C's blistering performance with a system that could actually keep massive code bases organized. Basically, they needed a bridge. Which brings us to Section 2, Birth of a Super Language. Bjarne Stroustrup, Levels Up Code. Enter our hero. Danish computer scientist Bjarne Stroustrup was working at Bell Labs in the United States around 1979. His mission was actually quite simple in theory, even if it was incredibly difficult to pull off in practice. He wanted to create a language that was just as fast as C, but natively supported object-oriented programming. He basically wanted to unlock these brand new abilities for large software projects without sacrificing a single drop of speed. So he rolled up his sleeves and started developing what he originally called C with classes. C with classes brought some seriously powerful new features to the C environment. Classes, objects, encapsulation, constructors, and functions inside classes. Now, what's really interesting about this is how these specific features finally made massive, sprawling programming projects manageable. They allowed programmers to bundle data and behaviors together, breaking everything down into logical, interactive building blocks. Then, by 1983, this revolutionary tool got a new name, and honestly, the aha moment behind the logic here is just brilliant. They called it C++. You see, in the original C programming language, the double plus sign is the increment operator. It literally tells the computer to add 1, or take 1 step forward. So the name C++ was this fun inside joke for programmers, while also being a literal representation that the language was leveling up. It was the next step. Moving right along to Section 3, Growing Pains and Standardization, Unifying a Global Language. Throughout the 1980s and 1990s, C++ absolutely exploded. It spread like wildfire, becoming one of the fastest growing programming languages on the planet. Developers were using it for everything: desktop apps, databases, graphics, engineering tools, the whole shebang. But that massive popularity bred a completely new problem. Different companies started creating slightly different, totally incompatible versions of C++ just to suit their own specific needs. So the crucial point is, without some kind of intervention, the language was at risk of becoming a chaotic, fragmented mess where your code simply wouldn't work on my machine. Let's move forward and see how this builds. To save the language, the international tech community stepped up and came together to standardize it. Starting with C++ 98, leaping to C++ 11, 14, 17, 20, and 23. Standardizing meant getting global agreement on the exact rules of the language. Every single new version introduced powerful, modern features while taking extreme care to maintain compatibility with older code. That's why code written back in the 90s can often still run perfectly today. Okay, Section 4. Powering modern video games, the engine behind the industry. This brilliantly illustrates how C++ absolutely dominates gaming. Major game engines, the heavy-duty software frameworks used to actually build the games, like Unreal Engine, CryEngine, and Amazon Lumberyard, they are all built with C++. Because of that, the blockbuster games themselves, Fortnite, PUBG, Counter-Strike, Valorant, the entire GTA series, are totally dependent on it. The exact same language powers both the foundational architecture of the industry and the epic titles you play at home. But why? Well, it really comes down to two words: maximum performance. Video games are incredibly demanding on a system. They require processing millions of complex calculations, crazy physics simulations, and stunning graphical renders every single second. C++ interacts so closely with the computer's hardware that it basically eliminates the middleman, and this translates directly to your reality as a player. It is literally the difference between pulling off a buttery smooth split-second headshot in Counter-Strike and experiencing frustrating game-breaking lag. For pure performance, developers still reach for C++. And finally, Section 5, C++ in today's world. 40 years later and still running the world. We have moved way beyond just video games, folks. Just think about these mind-blowing modern applications for a second. Artificial intelligence and machine learning, they rely heavily on C++ for those super fast, heavy computations. It's in the robotics assembling our cars and exploring deep space. It's the core of the operating systems running our phones and laptops. It's in embedded systems, like literally the computers hidden inside your microwave or your car's anti-lock brakes. High-frequency financial software, massive supercomputers, and breakthrough scientific research all absolutely depend on the raw, unyielding speed of C++. Millions of developers use it every single day. So if you're an aspiring software engineer, learning this language is for sure one of the most resilient, powerful investments you can make for your career. Which leaves us with this final thought. We've just traced this incredible journey from a tiny project called C with Classes inside Bell Labs all the way to the foundational code that is currently powering modern artificial intelligence, next-gen game engines, and global finance. The legacy of C++ isn't just in what it has already built, but in what it enables us to build next. So, my question to you is, what will you build for the future? Thank you so much for joining me on this explainer, and stay tuned as we continue to break down the incredible architecture of our world.